Linear systems are a great tool to be able to represent and solve different situations where there's a lot of different unknowns, and so we're going to take a look at a number of those different applications here. First of all, beginning with, at the midnight showing of Harry Potter and the Deathly Hallows, the concession stand sold small popcorns for 30 cents a piece and large popcorns for 50 cents a piece. In 10 minutes time, they sold 60 bags of popcorn for a total of $22. How many small and large popcorns did the stand sell during that time frame? All right, so ultimately, of course, the goal in this particular problem is to be able to solve for the number of smalls and large that were sold. We don't know that. We know that there were, it says 60 bags of popcorn. Some of those 60, of course, are small and some were large. So we're going to have a couple of unknowns going on right here. So let's define X to be the number of small popcorns that were sold. And then we'll define another variable for the number of large. How about Y? And so we'll want to establish some relationship or relationships to be able to kind of help us solve this here. So we do know that there were 60 total bags of popcorn that were sold. And so that would be the total of small and larges that were sold. So if I say just kind of generally the number of small plus the number of large is going to equal the number total that were sold, we know that that's really going to be X plus Y, because X stands for the number of small and Y stands for the number of large, and then that should equal the number total, which we actually do know happens to be 60. So that equation right there gives us a true relationship based on what we're seeing. Now, because that equation has two different variables, we don't have a unique answer because, for example, X could be 32, meaning Y would have to be 28, or X would be negative 2 and Y would have to be 62. Now, of course, that wouldn't make sense because it can have negative bags of popcorn, but you get the idea. So in order to get a unique value for X and Y, if that's possible, we need another equation at least to get a unique solution for two variables. So we do know the costs of these popcorns are 30 cents for a small and 50 cents for a large, and we ended up yielding a total profit of $22. So I think we could say that in order to get a total profit of $22, right, that we could take the number of smalls, and that's what X is, and multiply it by the cost per small, which is 30 cents. Now, note how I wrote that. I didn't write it as 30, I wrote it as 0.30, and that's a huge difference, because otherwise if you wrote 30, you would be wrong. And then it's 50 cents, so 0.50 times the number of largest. And that right there gives us another relationship kind of relating to the total cost. And so now that we've got two different equations, two variables, now we have a system that represents what's going on right here, and we can use that system and solve it to be able to find the solution to this problem. So we could solve by graphing, substitution, elimination, whatever you might want to do. I'm going to go ahead and do this by substitution method, and I think what I'll do is I'll take that first equation in the system there, and I'll solve and isolate one of the variables alone. So how about I do this? Let's get X alone. So if I subtract Y from both sides, then we know that that identity is true, and then we can do the substitution now that we isolated the X. So we can take 60 minus Y and plug it in for X into the other equation. So now what that's going to look like is 0.30 times the quantity of 60 minus Y plus 0.50Y is going to equal 22. And so then from this equation we should be able to find a value for Y. So if we multiply 0.30 with 60, that's going to give us 18. And then minus 0.30Y or 0.3Y and plus 0.5Y equals 22. So there are a couple like terms right there that we can combine together to give you 0.2Y. And then I'm going to go ahead and subtract 18 from both sides, which is then going to give me 4. So then if we divide by 0.2, then we should be able to get our final solution. And we do get an answer there of Y equals 20. And so with that, then we should be able to find X, and pretty easy to plug back into there, because if X plus Y equals 60 and Y is 20, then of course X would have to be 40. And so it seems that the number of smalls then would be 40, and the number of larges would have to be 20. And you could check to make sure that that also makes sense in the other equation in the system. So talking about this one right here. So if you did take 30 cents times 40 smalls, that yields you $12 even. And then if you added to that 50 cents times 20 larges, that yields you $10 for those. And 12 plus 10 does equal 22. So it works.